expected. Okay, so I'm not going to go over the bell work. I'll go over it tomorrow when everybody's back. All right. So we see on this, and by the way, if you're watching this, yesterday in class I gave you the wrong notes. So you can just jot this down on a different sheet of paper, or you can print out the notes. They're on Google Classroom under blank notes. So anyways, we're going to be doing these 3 things, and then we're going to have a homework quiz. We haven't had one of those in forever, but we will. It won't be till early next week, but just to let you know, you'll get to actually use your notes and homework on that. So today we're going to go over the extreme value theorem and talk about absolute extrema. And it'll be probably today and maybe, well, we're not going to finish it today, I'll put it that way. So here we go, the extreme value theorem. We learned back in this class how to find, and we did it in pre-cal too, relative min and relative max. And we can find it using derivatives, right? So, like, it's easy to look at a graph and tell, oh, this is our minimum, or this is our maximum, you know. But now we're going to also include with that absolute extrema, which we talked about last year, I think, last year in pre-cal, but I don't know, we may not have gotten to it. Last year was such a weird year. So first, we'll just define it. Relative extrema, that's maxes and mins, are points where a function changes.
Miss Kate.
Yes, ma'am.
Stephen and I need to go to the nurse with his things.
Okay, thank you. And now we have one. I'll record it for you though. You can get it. Send me emails if you have questions. From increasing to decreasing, or vice versa. So, basically where there's a hill or a valley. Absolute extrema are the points, or point, on a graph with the greatest or least, depending on if you're talking about mins or maxes, y values. So relative maxes and mins go at the top and the bottom of the hill. Absolute extrema can be at the top and the bottom of the hill, but it could also be at the end of the graph. This is weird. I feel like I should just sit down and let all the other people do it. Okay, so let's look at this picture. In this picture, I need it to move. There we go. We're going to find, if we have them, relative mins or min, and relative max or maxes. So Any mins? -3, 0. Yep. And to -6. Yep. Those are definitely both relative mins. They're at the bottom of the hill. And then let's do some maxes. Say that again. Yep. -1, 3 is a max. And they're both relative mins and maxes. Okay, then it says on the domain, what are the coordinates of the absolute extrema? So, we want to know if there are any. An absolute min and an absolute max. Okay, so looking at this picture, what's the lowest point period? Yeah, to -6. Okay, what's the highest point period? Is there anything higher than that? Yeah, all these. It keeps going forever, infinity. So there really isn't a minimum, or a maximum, sorry. Because it carries on up forever, we don't have an absolute maximum. But we do have an absolute minimum, because there's no point that's going to be below this, because both these arrows are pointing up. Okay. So absolute min is the lowest point, which was 2, -6, and there is no absolute maximum. Okay, now we're going to flip. Everybody write that down just in case. I guess they can pause it. We're going to flip to the other graph. Other graph's a little different because on the graph of g of x, it doesn't have arrows, so it's got a definite ending and starting point. We're going to start with relative extrema, just like we did on the other one. So we're going to try to find anything that's at the bottom of like a hill, or the top of the hill, or the bottom of the valley for relative mins or maxes. Okay, lowest points. -3, -4. And 3, 2. Yep. Those are both at the bottom of the valley, basically. Oh, did you find another one? Oh, max. You have -1, 4. That is absolutely right. And that's kind of like at the top of the hill. So it's done the same, even if it's not curved or doesn't have arrows. Relative mins and maxes work out the same. Absolute Okay, so looking at this graph, what is the lowest point period? Yep, -3, -4. And what's the highest point period?
6, 5.
Yeah. This is the highest point. It's not relative because I don't have anything on the other side to show that it's relative to something being a relative max, but it is an absolute max. So 6, 5. Okay, so then it says, on the domain of the given function, did the absolute extrema occur at the function's relative extrema. So, did the absolute mins and maxes occur, if they occurred, at a relative min or max? Here it did. Yeah, and on here it did. What about this one? No. Where did it occur here? Where was it on the graph? At the end. It was at an end point. That's absolutely right. So, I know one in green. On the graph of F, the absolute min occurred at a relative min, and on the graph of G, the absolute min occurred at a relative min, but its absolute max did not occur.